Hi, this is Dr. S and welcome to video 5 of reaction rates for Year 12 Chemistry. In video 4, we looked at how to measure the amount of gas produced in a reaction in order to come up with a graph that looked like this, where we had volume of gas produced as time progresses. And you should see that as time goes on, the volume of gas increases. You should also see that the reaction rate slows down. You can see it's steeper here than it is here, and ultimately it stops. When it gets to about 65 seconds, that's where it plateaus, that's where the reaction has stopped. So what we need to do now is use this graph to calculate and quantify an actual reaction rate in centimetres cubed per second. So how to do that is we need to take the gradient of that curve. Now it's difficult to take a gradient of a curve. In order to do that, we need to transform it into a straight line that we can take the gradient of. And that means drawing a tangent. So let's say that I wanted the reaction rate at 30 seconds. You can see this is the 30-second line here. So I want the reaction rate at this point here. You can see it's a curve. I can't calculate a gradient of a curve. But what I can do is draw a tangent to that curve. And you should be able to see that the tangent in my pencil line just touches the curve but does not cross the curve. And because it's a straight line, that allows me now to calculate a gradient. Now what I would recommend while drawing tangents is you go right back to the y-axis here, because it helps you to get an accurate reading of it. So now what I'd like to do is calculate the gradient of that line. Now to calculate a gradient, what I would do is then take 2 points that are easily to read. Now in this case, I would take the point here where it crosses the y-axis. So that's 28 and 0. And then I'll take another point that is relatively easy to read. I'm going to go for this point here. And that is at 42 and 53. Okay, so I had 0, 28, 42, 53. These are my 2 coordinates that are on my straight line. It allows me to now determine a gradient from that. Okay, so you can see that on my x-axis it's gone from 0 to 42, so the difference is 42, and on my y-axis it's gone from 28 to 53, so my difference is 25. Gradient to the difference in y over difference in x, so 25 divided by 42 would then give me my value. Now I don't have a calculator actually on me, and I'm using my phone to film the video, so I can't calculate what that is. But if you do 25 over 42, that gives you your rate in centimetres cubed per second. You should be able to see how you could calculate the rate of reaction at any particular point if you just draw a tangent at that point. If I wanted it at 50 seconds, I'd draw the tangent here, and you should be able to see that the tangent would be shallower, so I'd have a slower rate of reaction. If I wanted what we call the initial rate of reaction at 0, then I'd do a tangent up there, and you can see that the line of that would be much steeper, and I would get a much higher rate of reaction. Okay, good. I hope that's cleared that one up. In our next video, we will then look at 2 of the other factors that affect the rate of reaction. And the first one we'll look at is a catalyst. Okay, so I'll see you then.